lecture at one of the high schools in Toronto about the string theory, and my students had a really difficult time grasping the idea behind this theory. So I decided to make this documentary to help people better understand the concept behind the string theory. And I'm going to mainly focus on the superstring concept of the strings theory. And now I'm going to start off with a history.
So the goal of modern theoretical physics has been to find a unified description of the universe. As history tells us, this was a very fruitful approach. For example, Einstein and Maxwell's theory unifies the forces of electricity and magnetism into one force called electromagnetic force. Einstein used Maxwell's equations in his work to unify electricity and magnetism. Similarly, electromagnetic and weak forces can be unified into a single electroweak force. The four fundamental forces are strong force, weak force, electromagnetic force, and gravity. The first three of these behave very similarly as we approach higher energies. The goal of modern physics is to unify the fourth force, which is gravity, into this scenario, which might help us understand better about our universe.
Before we talk about anything else, let's talk about what the word dimension really means. Dimension is basically a number given to describe an object's position in a coordinate system. For example, if you had to describe the position of this point in a two-dimensional coordinate system, you'd have to describe its y component and its x component. In our world today, if we had to describe an object's position in a three-dimensional coordinate system, you'd have to describe its latitude, longitude, and its height. For example, this ball has three components, as you talked about earlier: the latitude, the longitude, and the height.
So why do we care about extra dimensions? This idea of extra dimensions goes back to the early 1900s. In the past, Newton knew the effects of gravity, but he didn't figure out how gravity actually works. Einstein resorted to the space-time curve, 3 dimensions, in order to describe gravity. So Kaluze, a relatively unknown German scientist and mathematician at that time, imagined that there was another dimension in this world, a fourth one, and used it to describe electromagnetic force using warps and curves. When he developed the equations, he encountered the old equations that Einstein used to describe gravity, and encountered one more equation due to the extra dimension. And that equation was none other than what scientists had been using to describe the electromagnetic force. This is where the idea of an extra dimension originally comes from, due to that one equation.
String theory looks promising when it comes to describing extra dimensions, since it changes our entire understanding of fundamental physics. From experiments, we have known that a large object, a box in this case, can be broken down into atoms, which further consist of a nucleus surrounded by electrons moving all around it. Nucleus consists of protons and neutrons. These protons, neutrons, and electrons consist of objects known as quarks. These objects are the basic structures that we know of from experimental physics.
String theory rejects our idea about thinking quarks are fundamental particles, the one that cannot be broken down any further. String theory proposes that the fundamental thing in anything is a one-dimensional string. Strings are dancing filaments of energy. The strings vibrate at different frequencies in different materials, giving them their unique properties. A string can be open or closed, and its length is approximately 10 to power negative 35 meter. Now that is really tiny.
Let's take a look at the wire on the chair. It looks one-dimensional, doesn't it? But as we get near it, that's when the three dimensions show up. String theory proposes that there are way more than three dimensions that we are used to seeing. They're just tiny and curled up, so we cannot see them, just like this wire from far away.
Problems with this theory, or let's say limitations, is that its equations don't work in 3 dimensions of space, neither 4 nor 5. It only works in 10 dimensions of space and 1 dimension of time. This brings us back to Kalutze's ideas.
Relativity, which deals with large-scale physics, unable to explain what happens within something like a black hole, which combines a very massive object that has an incredibly small size. String theory avoids the mathematical infinities by replacing the points of zero size in relativity with one-dimensional strings of finite size. String theory tries to unify gravity with the other three fundamental forces, something which has been very difficult to do. The graviton is an essential basic vibrational mode of the fundamental string. The graviton is the simplest vibrational mode of a closed loop of string. And that might help us unify everything if we can somehow prove the existence of the string theory.
So in the end, string theory all breaks down to these really tiny strings that vibrate at different frequencies in different objects that make up our universe as we see today. So in the end, I'd like to say that if string theory can be proved true somehow, it will be a great breakthrough for modern theoretical physics.